Hello, welcome to AP Calculus, Lecture 3.2. Today we're going to be talking about Rolle's theorem and the mean value theorem, and we're going to be working examples from page 167 in your book. You will need to print out the notes for section 3.2. It's just one page here. And if you want to do the example problems on the back, that's completely fine if you're looking to save some paper. So, just going to go over these two theorems. First of all, Rolle's theorem states that suppose f of a is equal to f of b. So when x is a, you have f of a. When x is b, they equal each other. So they're the same height. If there are 2 points where a differentiable function takes on the same value, all right, so f of a is equal to f of b, there must be an intermediate point where its tangent line is horizontal. So f prime of x has to equal 0. In other words, what goes up must come down, or vice versa. So the way I drew this, it's in the middle. Point C, where there's a horizontal tangent line, is in the middle. It doesn't have to be in the middle. Okay, that just made for a nice, pretty graph. That is Rolle's theorem. Okay, the mean value theorem states that consider 2 points, A and B, the slope of the secant line. So the slope of the secant line gives you the average value. Okay, go ahead. You may want to go ahead and write that down. So the slope of the secant line, think of that as the average value between the 2 points, will equal the slope of the tangent line. So will equal the slope of the tangent line at some point C between them. Okay, so this is just f prime of C is the derivative. And f of b minus f of a over b minus a is just the formula for the slope between a and b. So what it's saying is that there's going to be a point where the average value is equal to the instantaneous value. That's another way of saying this. So this is like y2 minus y1 over x2 minus x1. That's all that is. It's a fancy way of saying that. And again, I drew it kind of in the middle so you could see it really easily, but that point C doesn't have to be in the middle. Now for both the mean value, and when we say mean, what we mean is the average value. Okay, in statistics, the mean is just the average. All right, for both the mean value theorem and Rolle's theorem, the function must be differentiable and continuous. So if there's a point where it's either in between A and B, where it's not differentiable or it's not continuous, then these two theorems don't apply. So there may be one of your a homework example or two where you don't even have to work the problem because one of these theorems doesn't apply. So what I'm going to do is work 2 examples from the book for each of these theorems. So the first 2 are Rolle's theorem. And we're going to look at example 4 on page 167. Okay, so if you'll take a look at that in your book, the instructions say determine whether Rolle's theorem can be applied. So we've got to do that first on the indicated interval. If Rolle's theorem can be applied, find the value of C in such that f prime of C is equal to 0. So we want to know where there's a horizontal tangent line between the 2 endpoints. Okay, and so they gave us the interval, the 2 endpoints, and the function on these. Right, so for 4, we have f of x is equal to x squared minus 3x plus 2. And the interval is between 1 and 2. So the x values between 1 and 2. First of all, we got to see if Rolle's theorem applies. So f of 1 has to equal f of 2. So f of 1, we'd have 1 squared, 1 minus 3, that's negative 2, plus 2. F of 1 is 0. f of 2 would be 4 minus 6, that's negative 2, plus 2, 0. So, and this function, that's just a parabola, right? So there's no asymptote or break in this function. It's not a piecewise function. So it is continuous. So that means that Rolle's theorem applies. It's differentiable and continuous, and f of a is equal to f of b. So now we just take the derivative, set it equal to 0, and solve. So f prime of x would be 2x minus 3. I'm going to set that equal to 0. 2x is equal to 3. X is equal to 3 halves. And that's our point C. So in this particular case, it's the halfway point between 1 and 2, kind of like the one I drew. And at that point, 3 halves, you would have a horizontal tangent line. Okay, let's do another one, number 12. And number 12 has f of x is equal to cosine x. And our interval is between 0 and 2 pi. Okay, first of all, let's check and see if Rolle's theorem applies. So we're going to look at f of 0. Cosine of 0 is 1. And then f of 2 pi. Well, 2 pi, if you look at the unit circle, 2 pi and 0 are at the same spot. Cosine of 2 pi, also 1. And then the cosine wave, you know, that is continuous. There's no break in that. Oops. Okay, so Rolle's theorem applies. So now let's go ahead and take the derivative. F prime of x would be minus sine x. And we're going to set that equal to 0. Divide both sides by a negative. Sine x is equal to 0. All right, and for that one, where is sine equal to 0? So if you look at the unit circle, now we know sine is 0 at 0 and 2 pi. We don't want the endpoints. We want what point in between 0 and 2 pi. And we know that x is equal to pi. So you look at the unit circle, sine is 0 at pi. So at that point pi, we have a horizontal tangent line. Okay, so that's our two examples from Rolle's theorem. Now let me talk about the homework. You're gonna be doing several of these in this area of the textbook. And first of all, you always need to check, does f of a equal f of b? And if it doesn't, then you can stop. Rolle's theorem doesn't apply. Another thing is there a place within the interval that the function is undefined? So that could happen on any of these that have a fraction, like number 9 and number 10. So you need to check and see if there's a place in the interval where the function's undefined, then Rolle's theorem doesn't apply, and you can stop and you don't have to finish out the problem. Just write down Rolle's theorem doesn't apply. Okay, let's take a couple of examples from the textbook concerning the mean value theorem. So we're going to work number 30. So that's over a page on page 168. All right, so those instructions are: apply the mean value theorem to f on the indicated interval, and in each case find all values of c in the interval such that the derivative f prime of c is equal to the slope. So the slope of the tangent line is equal to the slope of the secant line. That's what that's saying. Okay, so Our first example, number 30, we have f of x is equal to x plus 1. Now, f of a doesn't have to equal f of b with the mean value theorem. Okay? So you don't have to do that test, but we do have to see, is there a place in the interval where it's not continuous? And our interval is 1/2 to 2. And if you look here, we do have a spot where this is not continuous. It's where x is equal to 0 because it's undefined there, right? However, 0 is not in this interval. So the mean value theorem does apply. So let's go ahead and first let's get the slope. That's going to be f of 2 minus f of 1/2 over 2 minus 1/2. I have to set the derivative equal to the slope. And here are our endpoints. Here's A and here's B. Okay, so f of 2, that's going to be 2 plus 1, 3 over 2 would be 3/2. F of 1/2, that'd be 1.5 over 1/2. So that's going to be 3. And then 2 minus 1/2 would be 3/2. So 3/2 minus 3 is negative 1.5, or negative 3/2 over 1.5. So that's negative 1. That's the slope of the secant line. We're going to set that equal to the derivative. So the derivative, f prime of x, is going to be, I'm going to use the quotient rule, the bottom, x, times the derivative of the top, which is 1, minus the top, x plus 1, times the derivative of the bottom, which is just 1, all over the bottom squared. So the x's will cancel and you have negative 1 over x squared. We're going to set that equal to negative 1, our secant slope. Let's multiply both sides by x squared, and I have negative 1 is equal to negative x squared. The negatives will cancel, so 1 is equal to x squared. So x would be plus or minus 1. But negative 1 doesn't fall within the interval, does it? So we can cross that one out. So x is equal to 1, and that's our value c. So that's where the slope of the tangent line is going to equal negative 1. It's at x is equal to 1. All right, let's do one more, and then I'll show you the homework, and we'll talk a little bit about the homework. All right, number 32. So in that one, we have f of x is equal to x cubed. And our interval is 0 to 1. Okay, so this is continuous, so that meets it. So let's take a look at the slope. So our secant slope would be f of 1 minus f of 0 all over 1 minus 0. So that's going to be 1 minus 0 over 1 minus 0, which is 1. So I want to set the derivative equal to 1 and solve. So f prime of x is 3x squared. We're going to set that equal to the secant slope. So we would have x squared is equal to 1/3. So x is equal to the square root of 1/3. Now it would be plus or minus the square root of 1/3. However, minus the square root of 1/3 falls outside the interval. So this is our point where the slope of the secant line, that's our x value, is equal to the slope of the tangent line. Okay, so the homework is going to start on page 167 and go over to page 168. But we will have 1, so that's just reading a graph, 3, 7, 10, 11, 13, 15. So 3 through 15, that's all Rolle's theorem. And then we're going to do 21. Now 21, you'll have to remember your velocity equation, but this is a Rolle's theorem type problem, so you need to think through that. It has you verify that f of 1 is equal to 1 and 2. What must the velocity be at one point in between? So think of that, what did we do with Rolle's theorem? Okay, and then we're going to do 27, 29, 31, 33. Those 4 are the mean value theorem. So for any of these, if it's discontinuous in any spot in the interval, or for Rolle's theorem, if f of 1 doesn't equal f of 2, remember you don't have to work it. Don't expect many of them to be that way, though. But it's possible that one of these you get to not do because the theorem doesn't apply. And then we have 43. I'll talk about that one in a minute. And then 47, 49, and 50. Those are true false that relate to our notes. Let's take a quick look at 43. So 43, you have to find the average velocity. So you're going to have to find the velocity equation and then find the average velocity. So your interval there is between 0 and 3 seconds. So you find the velocity at 0, the velocity at 3, and average those. That'll give you the average velocity. Okay, or you could do it by the average velocity would be the slope of the secant line. Okay, so you could just get that slope of the velocity function between 0 and 3. And then it's a mean value theorem problem on part B. So you would do it just like these problems over here, where you set the slope of the derivative equal to the slope of the secant line. So you set the derivative equal to the slope of the secant line and solve. And so, of course, you found, if you did it the way I just said, you'd find the slope of the secant line in part A. Okay. So that does it for this lecture. And I will talk to you on the solutions video.